Before we jump into the second section from Chapter 8, we're actually going to do a brief review on circles because the information in this section will help set up what we're doing with ellipses in the next section. So as a quick review on some things you should have learned in previous math classes, we have the standard form of a circle here. You'll notice it uses a lot of the same variables as the other shape we just looked at, the parabola. We still have an h and a k value, and the same rules still apply. H is always attached to the x, and k is always attached to the y. So those numbers that you see being subtracted, those will be the center of the circle. And then when you have the x squared and the y squared on the same side of the equation, there should be a constant on the opposite side. The square root of that number is going to be the radius. So using the center and the radius, that's usually all you need to be able to draw the graph. That's usually all the information you can really identify when you're working with circles. Some of the questions are going to ask you to identify the difference between a circle and a parabola. So just to point out, the easiest thing to look at to rule out whether it's a parabola or a circle is if you only see one of the variables getting squared. You see an x squared, but only y to the first power, then it can't be a circle, it has to be a parabola. Or the other way around, if you see y squared, but only x to the first power. So if you see x squared and y squared, it could be a circle. It could also be the next two shapes we're going to look at, but for now, x squared and y squared means circle. If you only see one of them squared, it's a parabola, and we've already gone over how to find the vertex, so that was just kind of a reminder from what we did in the last section. Your first couple questions on the assignments will literally just be giving you the standard form of a circle and then be asking you to write out the center and the radius from it, which is honestly just taking those numbers out from the standard form, or it might work backwards and give you the center and then just ask you to plug the numbers in. So I'll go over that a little bit in the next slides, but I'm actually going to focus on the harder types of examples that you'll see in the assignment instead. Okay, so first we need to identify what kind of shape we have here. Now, since I do see an x squared and a y squared in the equation, I know it can't be a parabola. It has to be a circle. So I can ignore the part that says if it's a parabola, find the vertex. So this one is a circle, but let's go ahead and get it into the standard form first. To do that, I'm going to be using the same completing the square process we used last time. I need to group together the x terms. So I'm going to have x squared minus 6x, and I'm going to leave a space so that I can complete the square in a minute. And then on the same side of the equal symbol, I'm going to have plus y squared plus 4y. Now the constant I do want to move to the other side of the equation because that's what's going to determine my radius at the end. So I'm going to add 36 to move that to the other side. Everything else stayed on the same side of the equation. I just rearranged the order. I was grouping the x's together and grouping the y's together. So now for the completing the square step, let me change colors for this so you can see that I'm making these numbers up. So you take half of the middle number, which in this case is -3, and let me write this again. It's 1/2 of b squared. That's the number we add for completing the square. So half of -6 is -3, and if you square -3 times -3, you get a +9. Now to balance that out on the equation, since I just added 9 to the left side, that means I need to add 9 to the right side, or my equation would not be equal anymore on the two sides. And then I'm going to do the same thing to the y piece. So I have y squared plus 4y, so b is 4. So if you take half of 4, that's 2, and then 2 squared is back to 4. So I'm going to add 4, and again I have to balance that out, so both sides of the equation. Now the reason we introduced those two numbers that I added in, it's because they do something very nice for the factoring part of the problem. It's always going to be the variable and half of the middle number, which in this case was -3. And you can confirm that's true if you want to FOIL out x minus 3 times x minus 3. You'll see that it comes back to x squared minus 6x plus 9. And then for the y piece, same thing. This was a positive y squared, so I'm going to have a plus in between. And then it's the variable and half of that middle number, which I used to square. So y plus 2 squared in this case. So we add those numbers because it makes the trinomial factor down nicely. Now on this side, I added some numbers, so I don't just have 36 anymore. 36 plus 9 is 45, plus 4 more is going to be 49. So at this point, you can compare this to the equation of a circle that I gave you earlier, the standard form. So when they said if it's a circle, find its center and radius, well, now I can see that the center is going to be, don't forget to change the signs, 3, comma, -2. And the radius is the square root of the number on the other side. So the square root of 49 is just 7. If you are asked to graph these, start off with the center of the shape. I'm going to use each tick mark as 2. So this will be 2, 4, 6, 8, just to make it fit on here. So my center was 3, -2. So I'm just going to put it out there for a second. And then we found that it was a radius of 7. So just go up, right, down, and left from your center, a length of 7. So up 2, 4, 6, and then half of one more, so that would be 7. And then the same thing to the right. So this going 1, 3, 5, 7, and then going down 2, 4, 6, 7, and then going to the left 1, 3, 5, 7. So I like to start off just by putting those points, and then that kind of gives me the outline of where my circle should be passing through. So be careful about using your scale as long as you label things in some way. If you need to do a different scale like I did, then just make sure that you communicate to me in some way that you were using different X and Y axis. Otherwise, I'll assume it's 1, 2, 3, 4, etc. So that's fine, especially when you have bigger numbers that you need to fit on. Okay, here's another similar example here. We're not spending a lot of time on circles, so I was just trying to refresh your memory on all of this. Now, again, it says if it's a parabola. Well, if it was a parabola, then I wouldn't see both an x squared and a y squared, and then I would be using the rules we covered in the last section. Since this one has both an x squared and a y squared, I know that that's not the case. So again, I'm giving you a circle, but you will have some pop up in the assignment where you have to recognize that it doesn't have both variables being squared. So first, we need to get this into the standard form of a circle. So I'm going to group together the x terms. So I have x squared. Actually, we don't have the other number, there's no x to the first power. So if you want, you can think of this as 0x for a second, if that helps you. But I'll show you what's going to happen with this. And then over here on the right-hand side, we have y squared plus 4y. I'm just rearranging the order. And then I need to move that -9 to the other side. So I'm going to add 9 to move it to the other side of the equation to set up my radius. Now, there was no x term. So what's actually happening here, you don't even need to use completing the square. This is just going to be x squared. You can think of it as x minus 0 squared if you want, if that helps you. Just to remember that when you don't have a 0x term, then that means that the center is at 0 for that variable. So my center is going to be 0 comma something. I do still need to complete the square on this part though. So on this one, let me change colors again to show you the completing the square part. So you take half of the middle number, which is 2, and square it, which is going to be 4. And then you have to add that to both sides of the equation. And the reason we do that is because now this will factor down nicely to be half of the middle number, which was 2. Unfortunately, on the right-hand side, I do not have a perfect square anymore, but that will happen sometimes. So that means that my center in this case is 0 for the x value and -2 for the y value. And my radius, since we can't break down the square root of 13, it is just going to be the square root of 13. And you might want to approximate what that equals in decimal form for purposes of graphing. You don't have to be super precise with this. But what's important is that I know that the square root of 9 is 3, and the square root of 16 is 4. So I know that this is somewhere between 3 and 4. So it's 3 point something. And you can put that into a calculator, which in this case comes to something like 3.6. So when we're trying to graph that, like I said, you don't have to be precise. I'll show you this in an example real quick. So first, we're going to list the center of the shape. Now on this one, I'm just going to use the standard scale. So 1, 2, 3, 4. So 0, -2 was my center. And then the radius was approximately 3.6. So from here, I'm going to go 1, 2, 3, and then not all the way up to the next line. That's all that really matters. And then going to the right, 1, 2, 3, and a little bit more. and going down 1, 2, 3, and it went off my grid a little bit. That's okay. 1, 2, 3, and a little bit more. So then just connect those dots. And then we can see the shape of our circle on there. So that should be it. That should be all you guys need for the assignments. Thanks.